Hey guys, Gareth here from Intent to Architect, and in this video, I'm going to show you guys what's wrong with most .NET teams' implementation of the soft delete pattern in the entity framework core landscape. And what we found is that in certain circumstances, when the soft delete is actually being applied, that data can actually be deleted. And this is something that as a team of engineers that focuses on automating patterns for the teams that we work with in the .NET space, we found this incredibly concerning as it is a major bug and something that we certainly do not want teams to run into in these particular edge cases. So just to jump in, when we do research around this and we do a quick Google search just as an example, and we type here enterprise grade soft delete patterns for the entity framework, we can see that there are lots and lots of links available for how to do a soft delete pattern. And if we go through these links, we'll see that by and large, these implementations are the same. Most implementations follow an interceptor pattern with a soft delete interceptor, which fetches out the entries that implement iSoft deletable, for example, where they are deleted. And then it will mark each of those from an entity framework perspective as modified. So we'll reverse the delete essentially and rather set a field on that entity like an is deleted field to true, and in some circumstances also set a deleted at, for example. And if we take a look around through some of those links that are highlighted over there, you'll see that by and large the pattern is pretty much the same. Here we can see that it's doing the same thing. It's fetching through the entries, it's fetching out the deleted ones where they are soft deletable, and it is setting them back to modified, is deleted as true, and perhaps capturing that timestamp. This is another implementation that does exactly the same thing. Fetches out the soft deletable where they're deleted, sets them to modified, and sets the deleted to true, and gives it a timestamp, and so on and so forth, right? It's the same thing over and over. Most teams implement their soft delete like this. And if I throw it to ChatGPT and I ask it for a robust, bug-free implementation, it will just do what we expect, which is to return back what most teams are in fact doing. And so here we can see that the interceptor is essentially just fetching out where they are deleted, setting them back to modified, setting the deleted is equal to true, and this is pretty much the same implementation as we've seen. Now, what I'm going to do is I'm going to show you guys what the bug is, and then I'm going to show you guys how we can fix this. So let's jump right in. What I've done here is I've created a sample app for us to work with just so I can showcase this for you guys efficiently. So we've got a very simple domain here with buyers, orders, order lines, and products. And what we've done is we've applied the soft delete to the product itself. And one thing I want to point out that is important here is that we have a price, and we have media assets, and these are both value objects. And that's important because typically how most teams implement the entity framework configurations for value objects is through owned relationships. You can also do the same for entities, but it's really around these owned relationships that the bug is exposed. All right, so let me just show you guys what this looks like in the code. So if we open up the entity framework core implementation, this is the configuration for EF, and let me just minimize this a bit to give us a bit more real estate. We can see the two owned relationships coming in over there. There's our is deleted, and this is very typical, by the way, of a soft delete pattern, is that you will have a query filter that essentially by default will query out all of the it'll just filter out all of the deleted records by default. If we take a look, there is our interceptor inside of our infrastructure. This is, by the way, just following a very typical clean architecture structure that most .NET teams follow. And here we can see this is a very typical implementation, pretty much the same as what we've seen in the on the ones for the ones online. We are going to fetch out our iSoft delete entries that are deleted. We're going to mark them as modified and set the deleted flag as true. And if we want to do a timestamp, we can do this within this method. That's really just some of the nuances of how this pattern can be implemented. All right, so the other thing that I do want to point out over here is if I go to my services, on my product service, I've got a service that I added to the very typical CRUD implementations, and that is that I created an additional service over here to get the deleted product. So this is giving us a window into the data that was in fact deleted through the soft delete. And let me just show you how that is in fact implemented. So if we go to our product service, and I just scroll to the bottom over here, we can see that when we go to our get deleted product, we're going to fetch out the deleted entries, right? And we're of course, we're going to have to escape the ignored query filter for the deleted so that we do in fact get these results back. So this is going to give us the window. This service is going to give us that window into what was actually deleted in our system. All right, so let's go ahead and compile this application and run it. This implementation has a Swagger UI by default. So it's going to launch up our Swagger UI and we can actually test this out. So just giving that a moment to launch. Here's our Swagger UI, and we can just go head over to the product. We can try it out, and let's just go put some dummy data in here so we can recognize it for later. So first test product of some sort. And let's give ourselves a price of 150, and we can execute that. We're going to get a 201. There's our ID. Let's copy that ID. And we can go and fetch this out. So typical of a CRUD implementation, we can just find our products by ID and we can execute that. And there we can see our data coming back with our price of 150. First test product is returning. Next, let's go to delete this product. And this is going to go through our soft delete pattern. So we can execute on the delete. We're going to get a 200, which means that this is successful. And now if we come back to our get product by ID, we'll see that we get a 404, could not find product and for this ID. And so this is our soft delete working as we would expect. And this is usually where most showcasing of the soft delete pattern ends. But let's go take a look at the data that was in fact deleted. So if we come back down to that service that we created to view this data, we can execute the service. And what you can see here is that it did return back our first test product. But what you will notice here is that our price is null and that our media assets have been cleared. This is the bug. Our data is in fact being deleted, and this is something that a lot of teams could be oblivious to if they have owned relationships. If you don't have owned relationships, you are probably not experiencing this bug, but if you do, this is something that you should certainly be concerned about. There's a very, very high possibility that some data could be being deleted if there are soft deletes going down on those particular entities. All right, so that's the bug. Let's go into how do we fix this bug. So a very easy way for us to just showcase this is I can just search for the soft delete module over here. This is essentially the automated pattern, and I can update to the latest version of this. We can run the software factory execution, and this is going to show us the change that it wants to make, which is really just on the soft delete interceptor. And if we double click that, it'll show us this is the change that it would like to make here. And what we can see is that where it goes through our entries, it marks them as modified, sets the delete, but then it also triggers a handle dependencies method, which is going to go through our owned one-to-one references as well as our one-to-many references that are owned. And it's going to mark those as unchanged, right? You want to set this to unchanged and not to modified, because typically speaking, if you are deleting something, you're not actually updating it. So there shouldn't be any issue with that. You could mark it as modified. That wouldn't be our suggestion, at least. And what is important is that this does happen recursively, right? So that is important because your graph could be very, very deep. You want to make sure that you're not just catching the first level deep. You want to catch the entire graph. All right, so let's go ahead and apply this change. We can come back to the code. And if we take a look at our interceptor, we'll see that that code has all been applied. And we can rerun the application. And we can run another test, which we can follow exactly the same steps as we did a minute ago. So as soon as this launches up, we can go to our product and we can try out our second test. So second test product with a price of 120, and we can execute that, receive our 201, and we can copy that ID and we can go find our product. And we can see that it is coming back. And then once again, we can take the same steps going down to the delete, and we can try that out. I can pass the ID into the delete. We get our 200. And once again, if we execute that, we get a 404 as expected. But let's go take a look at what the data that's been deleted looks like. So if we try out our products deleted, and we execute that, we can see both of our records coming back. There's our first test product with the null on the price and the media assets, but you can see on the second one, the bug is no longer in effect. It's been fixed. We now have our price and our media assets still there. So if we do need to recover this data, we can just set our is deleted flag, our column there for this particular row. We can set that to false, and we will have our data back without any data loss. So guys, that's the bug. That's how to fix it. If this is something that you guys if you guys have a soft delete pattern and you are in fact using own relationships, we would highly recommend switching over to a pattern like this just to make sure that you aren't losing any data. And if you don't have any owned relationships, you probably aren't running into this bug, but we would still recommend getting your soft delete in a position just in case someone on your team does decide to implement a value object or have an owned relationship in your entity framework. You do not want to have your data being deleted. So guys, I hope that was valuable. Please let us know in the comments below what you think, and let us know if there's any improvements that you guys can suggest. We're also always game to improve things and evolve. Until the next one, cheers.